Hi guys, welcome to this session on circular motion. So this is for P8 space, which is for separate physics. What we're going to do today is we're going to look at the properties of gravity, and we're going to be looking at circular motion of bodies, things like bodies in space. So to start off with, if we look at circular motion, imagine you've got a car. How do you get that car to go in a circle? Well, what you do is you turn the steering wheel, but how does that make it go in a circle? So if we imagine we're looking at this car from a bird's eye view, imagine that the car is going in a straight line and it has a constant speed. So what would happen if suddenly it did turn the steering wheel a little bit whilst maintaining the same speed? Well, what would happen is the friction between the road and the tyres would provide a force of friction, and that force would be acting that way. So if you were to take a snapshot of the car a second later, it would look like this. You can see that its speed is exactly the same. Relative to the car, it's still going in a straight line, but it's started to go in a circle. And if this friction continues, the friction will be perpendicular to this speed, and it will continue like this. So the speed of the car will constantly be in a straight line relative to that body. Meanwhile, this force that's causing it to turn will be perpendicular to it. And if you carried on the line of action of all those forces, you'll see perfectly straight lines here, you'll see they all point towards the same point. Now that point is the center of a circle. So what they do is they call this force that's causing the body to go into a circle a centripetal force. Don't get it confused with the centrifugal force. It's really annoying. Centrifugal force is fictional, it doesn't exist. It's something that biologists talk about when they talk about things like centrifuges and separating components of blood and stuff like that. But this is a centripetal force. It's the force required for a body to go in a circle. Now, a few things with the centripetal force. The faster that you are moving in a circle, the greater the force is required to go in that circle of that radius. And the smaller the radius of that circle, the greater the force required. So, for example, if this car was trying to go around the corner very fast, you would need a very, very large force in order to keep it going around in that circle. Hence why, if you're going too fast around a corner, you may skid because the road doesn't provide that centripetal force. And if a car tries to turn too sharply around the corner, again, it might skid because it needs a greater force in order to turn in a sharper circle. So you can apply this to different things. So if you look at something like if you're doing the old swinging a bucket of water on a string, it was literally the only other example I could find a good picture of. The bucket is going that way at that speed, and then the force is going towards the center provided by the string. In this case, the force would be tension, and it would go in a circle. What would happen though if the string were to break, if that centripetal force was no longer being applied? Well, what would happen is that the force would no longer be acting on the body, and the bucket of water would continue to move in the direction the speed is going. So hence what would it do? It would move in the direction this red arrow is going, and it would fly off. The same with a car. If you were to suddenly stop turning it, it would just go in a straight line. So what's actually going on here is that this force is causing this body to accelerate. Now that can be a little bit confusing because I've just said that in this case and with the bucket, it's going at a constant speed. So how is it accelerating? Well, you've got to think what the actual definition of acceleration is, because in P5, acceleration is a vector, which means it has magnitude, a size, a number, and a direction. And acceleration is the rate of change of velocity, velocity being speed in a certain direction. So this force isn't changing the speed at all. You can see the speed is the same all the way around, but it's changing the direction. Hence, it is accelerating. This comes up in P8, it also comes up in P5 of how is it that something can be accelerating going around a corner. It's not changing speed, it's changing direction, hence its velocity is changing. Another thing is they talk about work done. Is work being done onto this car? Work done is the energy transferred by a force. Now, the force has to be in a component that's not perpendicular, so this component is perpendicular to the direction it's moving. So what's actually happening is that this force is just changing the direction. The force is not transferring energy, it's not doing work. If it did transfer energy, then you would see a change in the kinetic energy of the body, Therefore, the speed would change. So in this case, when things go in circles, as long as they're going at a constant speed, there is no change in kinetic energy. There is no work being done. So let's go on to things like space and gravity. So what is gravity? Gravity is such a strange thing, and it took a lot of people to try and formulate what actually it is and what causes it. We're going to go with a sort of Newtonian way of looking at gravity rather than looking at Einstein's general theory of relativity. So when we look at gravity, gravity is caused by anything with mass. So if you have mass, you will have gravity. Now this can be anything, literally anything with mass. So we could talk about like a book on the table, we could talk about the table, the chair, me, whatever. We all have a force due to gravity. Even something like a proton or a neutron. But mass is dependent on the strength of gravity, i.e. if you have more mass, you have more gravity. And if you have something with small mass, like for example, the book, the chair, whatever, the force of gravity is so negligible just because it's that small. So when you look at something like the Earth, for example, the Earth has a mass of times 10 to 24 kilograms. The mass is huge. Therefore, the gravitational attraction has to be noticeable. Like the Sun, where it has a mass of times 10 to 30 kilograms. We're talking about a lot of gravity here. Even something like the Moon, which is about the sixth of the size of the Earth, will have a strong enough gravitational field for it to be noticed. So that's what gravity is. It's a force caused by objects that have mass, and it's always attractive. The thing is, if we look at this picture here, the Earth has a strong enough gravitational field that we'd notice it. The person is attracted to the Earth because of its force of gravity, but actually the Earth is attracted to the person as well. Now this might seem a bit strange. It's just due to the difference in masses that you wouldn't notice this. So for example, if you jump up, you will notice that you will go down because the acceleration of the Earth is that small, F equals ma. But if you've got yourself jumping up, you will never notice the Earth moving because its acceleration is that small. This applies to Newton's third law, essentially. If you have a body applying a force onto another body, that body will apply an equal and opposite force. When we talk about centripetal motion, though, we do kind of ignore this. So, for example, if we talk about the car here, you've got the friction of the car on the road and the friction of the road on the car. Essentially, we just talk about this one force going towards the centre of the circle there. Okay, so yeah, essentially this is what causes orbits. Force of gravity causes an orbit. The Earth will be moving at a speed in that direction. The force of gravity is going to be attracting the Earth to the Sun, and hence as it moves around, it's going to be constantly changing direction. So you will have this centripetal force. The same applies for something like a moon going around a planet as well. Now, as we said earlier, this centripetal force is dependent on a couple of things. It's dependent on one, how fast the object's moving, and two, the distance from one object to another. So for example, if you have two bodies and the distance between them is very, very small, then the force required to have them in orbit with each other and have the moon, for example, moving in a circle around the sun would need to be very, very high. If the moon was further away, the force would be very, very small. And the speed as well. If the moon was moving very fast, it would require, for that orbit, a large force to move around at that radius. So it depends on what force can be provided here. So the force is due to the gravitational attraction between the two bodies. If you have an object moving further away, it requires less force, so it can move faster. If you have an object that's very close and moving very fast, it would need more gravitational force, a larger centripetal force, to move in that orbit. Which we said, think about it like the car. If you have a car moving around a corner, if it's moving too fast, it doesn't have the friction to move in such a small radius at that speed. So what will happen is the radius will increase, the car will skid, in order for the gravitational force to be equal to that centripetal force. This is going a bit into A level here, but essentially if you move faster and if you move with a smaller radius, you will require a larger centripetal force. Okay, that's it. Hope you enjoyed. See you next time.